What I'm going to do today is show a more concrete way to visualize all sorts of transformations. So whether that's a translation, a reflection, or a rotation. Because what I found is a lot of math today, we are either just telling students to memorize the equations, we're just telling them to visualize it in their head, or we're just like using geoboards and stuff that it takes like a lot of counting and not really seeing what's going on. So I'm going to use a method that the math professor showed me here at Central. That all she did was use wax paper. So she had an image, then she'd put wax paper over top this image, and then you trace the image, and then after that you can either rotate it, reflect it, you can do whatever transformation that you want. So what I'm going to do is I'm just going to give an example. The first thing that you need to do is overlap the axis, because if you're trying to use this as a guideline, you're going to have a rough time because they might seem perfectly square, but they're not. You're going to have these rough edges. So what I would suggest doing is completely overlap these axes and put a dot on the origin, somewhere on the y-axis, and somewhere on the x-axis. Now the reason why you want to do that is because that way if you take it off, you can put it right back on where it's at. Or if you do a rotation, you just keep the origin in the same spot, then you just move a line over to make sure there's one on the x-axis and one on the y-axis. So everything you're going to be doing, you're going to be referencing these three dots. You're not really going to be looking at your triangle or your image after you start moving it. You're only going to be looking at these dots. So first off, you can use anything to really draw on this except pen. Pencil works. Expo markers work nice for middle school because we found that they don't like to use pencil and paper, so you can just put a dot on here. You can erase it pretty easy, or you could do an image, and you can do multiple images. You just erase the image, do a new one. You can use the same piece of wax paper multiple times. So I like using expo markers, but I would just be careful making your dot too big, because if you do one of these, then it's going to be hard. Okay, is this on the line or is this one on the line? So like I said, I would suggest using small dots and mark the origin, the y-axis, and the x-axis. Now after you have these three dots, which are really important, go ahead and trace whatever image you have. So in my case, I just have this triangle. So I'm going to just trace my triangle. And once again, I would try and make your lines as small as possible. I realize these are expo markers, so it might be difficult. So make sure you either have a small enough expo marker or these squares are big enough that it's not going to make a whole lot of difference. Because if you have very small squares, it's going to be hard to tell because they're going to land right in the middle somewhere. So make sure your squares are big enough that you can distinguish between what square you're going to be on. Now the first thing I'm going to do is write what coordinates are which. So I'll label this one A, this one B, and this one C. So that way when I rotate it, I know which one is which. And I have A equals, this is 1, 1, and I have B equaling 2, 1, 2, 3, so B is 2, 3, and then C is 1, 2, 3, 4, 5, 1. Now the nice thing about this is after you start doing some rotations, reflections, translations, students can start noticing patterns. So those are going to be your more abstract thinkers, the ones that can start generating equations just by doing it a couple times. Now you're also going to have some concrete thinkers that are going to need the wax paper every time, and that's perfectly fine. I mean, engineers today still use this type of method by seeing where everything's going to be, or interior design, clothing design. They use this type of method, so it's perfectly fine if they want to keep using this on tests, quizzes, stuff like that. Because in my mind, as long as they can see what's going on, they really understand what's going on, that's more important than memorizing what happens when a 90-degree rotation. Okay, well the signs switch, one turns in it. That's just complicated. So if you just use this method, it'll work every time. Now what I'm going to do is start off with a 90-degree rotation counterclockwise. So what I'm going to do is this y-axis now needs to go to the x-axis, and this x-axis goes up to the y-axis. So this is going to be my 90-degree rotation, and the origin needs to stay where it's at. So you can just rotate it, put the origin there, the y-axis and x-axis. Now this is your new triangle after a 90-degree rotation counterclockwise. So you can go ahead and write down these new coordinates. So A prime in this case would be 1, 1, and B prime, oops, in this case would be negative 1, 2, 3. Oh, negative 1, and in this case it'd be negative 1, 2, 3, negative 3, and positive 2. And C prime in this case is going to be negative 1, 1, 2, 3, 4, 5. So negative 1, 5. Now, like I said, students might already start noticing some patterns. So before, if you're a math teacher, you know that the equation for this 90-degree clockwise is you'd switch the signs. So in this case, A it was 1, 1. Now you're going to switch the signs, so it'd still be 1, 1. B would be it was 2, 3. Now it's 3, 2. And then you make your first number negative if it's counterclockwise, because you can just look at what quadrant it's going to be in, that since these x's are negative and the y's are positive, you know that this x needs to be negative and this y is positive. Now they can start noticing these, or you can just have them keep writing them down. This is fine. So this kind of differentiates for you that you can have your concrete thinkers can always be using this wax paper, and your more abstract thinkers can be like, okay, no, I know what to do now. And that's perfectly fine if they start realizing what they need to do. Now I'll go ahead and do another demonstration. I'll do a reflection over the y-axis as well. So since it's a reflection, I'm going to keep my axes the same. So this one's just going to go over here, and these two are going to essentially stay in the same spot. So I'm just going to flip it over, just like that. And now I have the origins the same. Now remember, you're just going to be looking at these points at first, and then you can start looking at, okay, well now this is at negative 1, 1, this is at negative 5, 1, and this is at negative 2, 3. And if you notice, that is just making all these first numbers negative. But students can decide to use this wax paper, or they can start generating their own equations. You can decide. But this is a good activity to have students start realizing what's happening when you start rotating images like this, or if you start making reflections, or if you start doing a translation as well. You can just move it up 2, you can move it over 1, and then you have a whole new image that you can write down. So thank you for watching, and let me know if you have any questions.